Hey, welcome back to Fat Mama Physics. This is the third video for going over Fnet and free body diagrams. Here I have an example and a follow-up example for you to try and me putting solutions on Fast Play. So let's get to this example. We have Team Rocket just blasting off at the speed of light. Okay, I'm just kidding. On the way down, they reached terminal velocity. If the force due to gravity acting on them is 2,100 newtons, how much force due to air resistance are they experiencing together? Okay, so let's first start with a free body diagram. I'm going to draw Team Rocket as just a circle. Oval, I mean. Okay, and put a dot in the middle. We know that if Team Rocket is falling through air, or if it's in free fall, there is the force due to gravity acting on them, Fg, and we know what that is 200 newtons. And we also know that there is air resistance acting on Team Rocket, and because they are moving down at terminal velocity, the acceleration is 0, meaning they're not gaining speed, they're moving at constant velocity. So that means the air resistance should be equal in magnitude as the force due to gravity. Sometimes we call this F drag forces. Okay, so these two are equal in length. And there's our free body diagram. Oh, and one more thing, I am going to label the downwards direction as the positive direction. Not something we've done before, so let's get used to it. Next up, we are going to look at how to calculate this. Right now, we're trying to find the force due to air resistance, and we know that Fnet is our sum of our forces, and Fnet, in our case, since Fg is positive now, in the positive direction, I have Fg minus Fair. That's my Fnet along the vertical axes right now. But right now, we only know Fg. We don't know Fair, meaning we need to know Fnet in order to figure this out. Well, let's think about this. Fnet is ma, and we know we actually don't know the mass of Team Rocket, but what we do know what A is. They are falling at terminal velocity, telling us that A is 0. If acceleration is 0, that tells us Fnet is also 0. So this is 0. All of the Fg minus Fair is equal to 0. So let's write that down again. And if we move Fair to the other side, then we get Fg is equal to Fair. We know what Fg is. Fg is 2,100. So the air resistance, force due to air resistance, must be exactly the same thing, but in the opposite direction. I'm just going to label this up, okay? And you might have thought, oh, why did you go through all of that if you knew they were equal in the first place? It's just going through the process of doing the Fnet equations, because you're going to need that for the next problem, which I'm going to give you a chance to try right now. So let's just make sure we understand the problem. Before Team Rocket, there's something there, reached terminal velocity, before they reached terminal velocity, they were falling down. There is a point they were accelerating downwards at this rate. We continue to use the force due to gravity as 2,100 newtons, just like the previous question, but this time you are calculating the force due to air resistance acting on them. So kind of a one notch up from last question. Okay, so good time to pause the video, and I will play the rest of the question on Fast Play. And here I go. Starting off with a free body diagram, I'm going to draw Team Rocket as an oval, Fg pointing downwards, and Fair is going to be shorter because we're not falling at terminal velocity. There is acceleration in the downwards direction. With Fnet equals to Fg minus Fair, we first need to find the Fnet first, which we have the acceleration and the mass, and that's going to help us find F air. So let's calculate this one out, putting in our values. The direction downwards is positive, so don't have to worry about that. And putting in our calculator, we get 1480.6, keeping all of our digits because we're not done yet. Substituting into Fnet equals Fg minus F air, we will need to isolate for F air by putting Fg on the other side. Calculating this one out, we get negative 1051.4. The two negatives cancel out, which will leave us with F air is going to be 1051, but actually it's going to be 1100 newtons in the upwards direction, rounding up. Okay, so here we have the force due to air resistance is 1,100 newtons acting in the upwards direction, where we've just rounded this value to two significant figures. You might be wondering why I got a positive value in the end, even though it is acting against the direction of my motion. The reason because of that is in my Fnet equation, I've considered the directions already by subtracting that from Fg. So I should get a positive air resistance value because of that. Otherwise it wouldn't make sense to get a negative of a negative. Alright, so hopefully you learned something from this question, and hopefully you have enough tools for you to use to start doing practices on your own. Good luck with that! And thank you for watching this video. Fat Mama Physics signing out.